and science method. There are many different types of beautiful graphs: line graphs, bar charts, pie charts, histograms, scatter plots, just to name a few. So how do you decide which one you need to use? Well, in this video we're going to look at two of the most common graphs, line graphs and bar charts, and show you how to choose which one you need to use for your data. So if you want to know how to do that, keep watching. So here I have two tables of data, and I'm going to use these to illustrate when we use a line graph and when we use a bar chart. If you haven't already watched our video on types of data, continuous versus discontinuous, I suggest that you pause now, go and watch that video, and then come back. So if we look at this table of data here, we can see that I've got continuous data. My distance is a number, runs from 0 to 10, and number of rows is a number as well, running here from 64 down to 5. Okay, so I could have numbers in between each of these. And for this table, I'm going to use a line graph. So we always use a line graph when we have continuous data. If I look at this table over here, however, I can see that I've got eye color, blue, brown, green, and number of learners. Now if I look at the eye color, I've got 3 different categories, and I can't get halfway in between. My eye color isn't a little bit blue and some brown, or brown and half green. So I've got different categories, so it's discontinuous data, and for this one I'm going to use a bar chart. Now to plot this data, what I'm going to do, I'm going to start with my first point, which is 0 and 64. So I'm going to come across the x-axis to 0, and I'm going to go up to 64. Now because I've got a nice scale here, every centimetre is 10, that means every millimetre is 4. So I can measure up 6 centimetres and 4 millimetres, and I'm going to put my mark over here. Okay. Now don't estimate where it is, measure it exactly by using the ruler. So once I've done that one, I'm going to tick off that I've done that point there. I'm going to move on to the next one. So once I've got all my points, what I'm going to do is, because this is a line graph, I'm going to join them dot to dot. And that's it, that's my line graph. Now something to be aware of is not to get caught out. I'm just going to sketch a graph. Let's say, for example, I had my points look like this. I would join them dot to dot using a ruler, okay? But now let's say in my table I only have these points here. Sometimes people draw a line from 0 to that one, okay? That is incorrect. Unless you have a point at 0, 0, do not draw this line. So you only draw lines between the points you're given in the table. So here I've got my bar chart, I've drawn my axes. In this case I haven't written a title, but you know how to do that. If you don't, please see our previous video. So what I'm going to do, blue eyes, 5 learners. I'm going to come across here as my blue, and again I'm going to use my ruler and measure up exactly 5 on the other side, join it across the top. And I can just double check that it does line up with the axes, and there's my bar. Okay, and a top tip is make sure that when you're measuring, okay, you measure exactly to the 0 line, not to the end of the ruler. Remember there's a bit of a space here, it needs to go to that, not the top. And there we go, nice bar chart. As a bit of an extension to the idea, sometimes you'll see some data which is a bit like this. I've got age, and it's split into chunks, 0 to 5, 6 to 10, 11 to 15, 16 to 20. So age is kind of a continuous variable. It can be anywhere from 0 to 20 or more. But in this data set, it's been split into chunks of 5 years. And maybe this was from a survey and it just said, is your age between 0 and 5? Is your age between 6 and 10? So they recorded that it's between 0 and 5, but not the exact age. So when we want to represent this on a graph, we're actually going to use something called a histogram. Now, a histogram is similar to a bar chart, but it's used with this kind of data which is kind of continuous. And you'll see that on this histogram that I've drawn, there are no gaps in between the bars. And that's showing that the numbers can vary in between, but it's just been split into these different chunks like that. So bar chart, different categories, there's a space. Histogram, we've got this kind of continuous variable, but it's been split into chunks and all the bars are touching. Let's consider this graph I've got here. I've got some generic variable x, variable y, my title, and here's a set of data. Now maybe this is, could be the rate or the amount of light versus the rate of photosynthesis. Now I could draw a line graph on here and join all these points together, but there's a little bit of a problem with that, and that's that we can consider that this is an experiment, and so each of my recordings here might be a little bit inaccurate. So there could be a bit of error in each of these points, it could be up or down. And I might want to know what's in the middle. So I measured these points, but maybe I want to know, well, what was it when it was halfway in between here? If I join the dots, I don't really have a way of working out what that point could have been. So to get around that, what I can do is draw something called a line of best fit. And that's where I'm looking for a correlation between this variable and this variable. So I think that this one has an effect on this one. And I'm going to have a look at my line, which is going to show me the pattern, and it's going to help me to fill in any of the blanks that I didn't record. So the first thing to do is look and see, is there a pattern? Well, yes, it looks like as I go across here, it increases. But there's one that doesn't fit the pattern, and that's quite clearly this one. So this looks like it's an erroneous data, maybe I made an experimental mistake. So I'm just going to circle that one and leave it off. And I'm going to use then these points to plot my line of best fit. So my line of best fit is going to try and go through as many of these as I can. So I'm going to start there and end here, and it looks like I'll probably go one above, one below, the other ones are more or less on the line. So I might draw something like this. And I can see then that this line of best fit is showing me the pattern, and I can see that I've got a few above, a few below, but it kind of goes in between most of the points. So importantly, it's going to connect to the y-axis. So this means that I can measure all these variables here, all these points. I didn't measure this one here at 0, but I can extrapolate back and work out what it should be. It also means that this one where I made a mistake, well, I can see that actually it should have been this value here, and this one could be this value here. So I've got a way of working out what those values should have been. And I can also see that then here's a bit of experimental error, a little bit above and below where I would predict the line to be. So that's a scatter plot and a line of best fit.